This is the light entertainment after dinner. So those of you who have been to these conferences before will perhaps spotted a pattern that my presentations are getting steadily less and less technical as my mental faculties fade. And it's tonight is continuing that progression. And I'm really on a loser here because I think that what I'm going to do is three things. I'm going to do the same pitch that I gave at the gig in April, with many of the same jokes, many of the same mistakes, and then we'll have a little session of question and answers. So anything you ever wanted to know about Dyalog Systems, Dyalog Limited, but were afraid to ask, now is the time. And then I've just tacked a little I crave your indulgence. I've got a little technical note that I want to tack on to the end of this presentation. So there's just a little bit of geeky technical stuff, if you bear with me. But I'll leave that to the end. Now, first thing, let's do audience warm up. Right, you ready? Put your hand up if you have a hand. Right, keep it up. Put your hand down if you came to the gig in April and heard this before. So we got a few people. Okay, we got a few people who've not heard it. All right, that's good. Thank you. I didn't do that in April, so that's new. Yeah. All right. What? Just stretching. Okay. Thought that was a question. This is an impossible thing to do. So to give a flavour of the history of Dyalog APL, and necessarily I'm going to leave some people out. I'm going to cause offence, which I apologise for. The only way I can do this fairly is try to give offence to everybody uniformly. So if at the end of the talk you feel I haven't offended you, maybe you could raise your hand and I'll try to think of something. I'll pull something out of the hat. We did discuss this, how we're going to offend so many people, and I think I'm going to have to do it in blocks. I may have to take the Danes or the people with not much hair or something to... Yes, offence each. All right. The other thing that makes it, in a way, it's more difficult, and in a way it's a little easier for me, is that Peter Donnelly was there at the pitch in April to keep me honest, because he was there all along, and Pete has a much more objective view of the situation than I have, effectively as a typist sitting there watching things go by. So I'm hoping Jeff will keep me honest this time when I make extravagant claims. I think Jeff and Ray. I guess there are a few of the old timers here. All right. So this will not take as long as you might think. Let me start. This is my version of PowerPoint. Sorry? Oh, 11. Sorry, I meant to start 12. No, what? Okay, that explains a lot. That's because I got the wrong... No, yeah, there you go. Okay, happy? Thank you. Well, maybe this is... Yeah. What always happens... Right, let me see if this works. Yeah. Now, with any luck, we'll get... Yeah, look at that. Great. This is the way that... sorry, the other thing I should say before we get into this is let's have another show of hands. Put your hands up if you have a hand. Put your hand down if you're an APL programmer. So... Okay. All right. So we have a few non-APL programs. Thank you. So the pitch in April was a really tough call because... Effectively, it was about 50-50 split of programmers and normal people in the audience, and one of the tasks was to keep these people out of trouble for about an hour while they were preparing They didn't care what I said, what happened, as long as I kept people in the room. And I explained to Vivica that if I sat my wife, Flora, in front of a technical presentation for an hour, there would be violence. And so we sort of had to mix it up a little bit. And with the indulgence of the... Okay, well, I'll come back to that in a moment. I'm already out of shape. So for APLers, this is the way that we measure our lives, I think. If you say, what were you doing in 1994? People would go, Antwerp. Oh, yeah, I was doing so-and-so. These are the APL conferences. This is just a historical map of the conferences. Please, if you see, I believe this is correct, but if you disagree... Sorry? 84 was Heidelberg. No, Heidelberg was 82. Manchester was 86. Yeah. And I think this is good. And what you'll notice is they oscillate between the US and the non-US. You could say US and Europe as long as Sydney is in Europe in 88. Is Toronto not in the US? Okay. All right. Yeah. Toronto was so good that we went there twice. But these are these things. And what I should have done, if I'd not been an intensely lazy man, I should have researched more of these when we announced things. I can't remember which conference we announced namespaces, for instance. Can anyone remember that? Where people first saw dots? Well, namespaces sort of oozed in. They came within quotes to start with, didn't they? And they didn't quite appear. 92, 93. I think Berlin refs. Yeah, Berlin was refs. But so they'd been away for St. Petersburg maybe. Yeah, Toronto. Okay, so this is St. Petersburg was namespaces. Well, what WC? Well, I thought there were refs in Berlin. Well, I'm going to put refs in Berlin. Does anybody want to argue about that or not? Yeah? No? Okay, the duck. That was one of the questions. Can we save the duck to the end? Can you remember that and ask when we have questions? Throw the duck question in. Yeah. Okay. I'll yeah. Okay. So this is. Me move in front of the... Oh, yeah. Yeah. Okay. And many more. I don't know if anybody else has got any... make you do the work. What else is significant? What else did we do? Ducks, no, okay. We'll come back to it. Ducks was the CGI interface. So I'm going with Seattle for that. I think Seattle for... Oh, that's an interesting thing. Okay. Yeah. Are they a year out? So what there was? So this is the third health single. Ah. I've got this completely wrong then. Surrey and San Diego were the same. Yeah? And then, sorry, what are we saying in 2004 then? Naples, Florida. Yeah. I'm working on it. Just good. I've insulted Canadians. Yeah, that's 4 Canadians. What are we writing in 2005 then? So there were 2 in a row. Yeah, it's the whole system's shot now. That was so good. Yeah, are we going with that? Yeah? Oh, okay, near enough. Yeah? Oh, yeah. Which was in Spawn, ampersand, Spawn in Rome. Threading. Oh, yeah. Yeah. Is that in? Yeah. Where are you going for, Antwerp or St. Yeah. Anyway, we must go quickly. We're going to run. Okay. So that's that. This is a really thin presentation. There's 4 slides and 2. I'll do the jokes. Shall I do the jokes again? The people that saw it. Yeah. Do you want the jokes again? Same jokes. All right. It's the same jokes as most people have seen these jokes. To explain the difference between computer programmers and normal people, there's 2 jokes. One joke might appeal to computer programmers, and the other joke might appeal to normal people. Or probably better, one joke won't appeal to computer programmers, and the other joke won't appeal to normal people. So it's a slight difference. Right, you ready? See if you know which one this is. I'll tell you. This is a computer programmer's joke. You ready? This is joke A. Ah! Yeah. And this is funny to joke B is funny to normal people. I've no idea. Oh, joke B. Joke B is apparently this is funny to normal people. What is the computer programmer's idea of foreplay? Yeah. That's 2 jokes. So this is nearly over. All right. This is perhaps a more interesting. No, I'm not. There's no chance. Right. What this is a surprising number of people have worked. This is my way of offending a lot of people here. This is a lot of people have worked on the Dyalog APL product, and I choose my words carefully. It's really hard because it's a sort of fuzzy thing. You know, we've had people who have come in and done documentation, and they helped, they did things. But I think these are mainly people who have typed, whose fault it is when we can blame when you get a bug. So I'll just go through these, and the way we're measuring this is that we have been. Sorry, I'm not very good at this. I dodge around and point. I've got one of these pointy things here. Yeah. The way we measure this, Dyalog has been in many different offices. This is the only way I can remember. So we started off. The company was based in Epsom in Surrey, and the original company was set up by 3 partners: Ted Hare, David Crossley, and Phil Gosher. And David Crossley is still a Dyalog user, and we hear from him quite often. And Jeff Streeter was I think you were a founder member, Jeff. And John Stembridge. Where's John? Is John with us? He come? He didn't come. Okay. And that, in that case, oh yes, I have got him there. Yeah. So Dyalog was set up originally as an APL consulting. Dyadic Systems, as it was called, was set up as an APL consulting shop. And so it was effectively a body shop. The people, there wasn't an office, as I understand. People worked from home, and they met every month at one of the directors' houses and had dinner and talked about what was going on. I seem to remember coming into that late. And we, at some point, this was before my time, Dyadic Systems, I think, saw the consultancy market declining and decided the way to the future was to have their own interpreter. That we should write. I'll come on to that in a moment. And at that point, Jeff and I were installed in an office in Maidenhead, and Pauline Brand was one of the original founder members. All the people that were in Epsom were the founder members of the company. And Pauline Brand's sister was the European marketing director of Dyalog Limited, where Dyalog was an 8-bit chip and then a 16-bit chip. And Dyadic Systems did a deal with Dyalog where they threw in office space and machinery, Dyalog, and a computer, and we threw in Jeff Streeter and JohnScholes. And the Dyadic Systems and Dyalog together gave the product its name of Dyalog. That was the... That was how that came about. And there were a couple of near squeaks. Dyalog were very keen that we write they wanted an interpreter for their 16-bit mini computer. They wanted an APL so that they could put a tick in the APL box. And they were very keen that we write it in their homemade system implementation language called PLZ Sys. Had we done so, we wouldn't be here today, because it would only run on the Dyalog. But we stuck out, Jeff and I stuck out to use C because we figured we'd have a chance, if the project lasted more than a year, we'd have a chance of moving it. So Jeff and I started typing in September 1981, and we learnt C. We'd used other systems, I'd used other systems implementation languages, but I'd not used C. We learnt VI, and we started. So in September 81, and we showed release 1.0 at the Washington conference in April 83. That was it, yeah. So it took 14 months for two guys to do a second generation APL. And I'm really glad Pete's not here, because Pete's view of that was it took two guys 14 months to produce a prototype of an APL. Because it didn't have, it was quite slow, it didn't have optimizations in. But it had most of the language in, I think. Jeff, is that fair? The problem was he didn't have any of these, plus reduction, for example, the reduction said, oh, I've got a function to my left, and it just did a general case. It did the same case as foo reduction, so it would make a nested array result in case foo returned a non-scalar, and then it churned through. So it was general. It met the language. Oh yeah, it did foo reduction, which was amazing in that. Yeah. Okay. So there are a couple of these. So we did this in Maidenhead for about, I think we were there for about 2 years. This is just Jeff and myself. And then we moved to an office in Farnborough, where many of these people were. So I don't know, a lot of these people, Ray's with us. Ray was a founder member. Some of these names are amazing. Adam Curtin was at the bash in April, and he did the original IDE, the tracer editor, and he did Quad SM, so he did a huge amount. Dave Gordon, who we've seen recently, wrote the display. When you display an array, it's all lined up nicely, a nested array. You know, if you display a nested matrix, all the columns line up and the rows line up. And Dave did that. I should mention Camilla St. Clair Ross Martin. I didn't have enough room. What you'll notice is that she wasn't actually anywhere. And this is just part of the dialogue folklore that if she did have a slot, it would be here. Peter, this is actually quite a shameful story. It may actually be illegal what we did, but we were in the Farnborough office and we were recruiting, and we had a phone call from Camilla St. Clair Ross Martin saying that she'd seen our advert. She was just going to come in for an interview at 4:00. And she was very assertive. We were a bit gobsmacked, and we said, okay, yeah, fine. And come 5:00, no Camilla St. Clair Ross Martin. Come 6:00, she waltzed into the office, 6:00 in the evening. And she was something from the front cover of Vogue magazine. She had, I couldn't speak. I turned into an 8-year-old schoolboy. I couldn't speak. But Pete was a bit more worldly wise than I was. And she interviewed us, effectively. I might take a job, I'll sit quietly in the corner. She didn't, to our defence is that she didn't know any programming. She didn't know C. She didn't know anything. But she was prepared to sit quietly in a corner and learn to program. Nobody would notice her. And then she waltzed out again. And actually, the story, I think Pete's story is that at that time, Pauline and Leslie Gould were the glam in the office, and there would be trouble. So, I mean, quite apart from Camilla wasn't actually a programmer, so we couldn't offer her a job. But apparently, Pete was at a Unix exhibition in one of these great aircraft hangar, vast exhibitions, 2,000 or 3,000 people, blokes at a Unix exhibition, and he said he noticed that everybody stopped talking at some point, and Camilla St. Clair Ross Martin waltzed by the stands to one of the Unix stands. So she got a job as a computer programmer in the end. Yeah. I think she could have had us up in the Gender Discrimination Act or something. I don't know. So these are the things. Yeah. Oh no. Oh, Saqib. Sorry, Saqib was I probably missed Saqib out of delicacy, and you've now embarrassed me. Yeah. Yeah, I'm scrolled. That's as much as we've got. And I had to scroll everybody up because we've suddenly got. Oh, you see, there's two Richard Smiths here. Look, Richard Smith and Richard Smith. Richard Smith worked for us for a while. Richard Smith 1 worked for us for a while, had a desk, and Richard Smith 2. And Matthew Streeter, Jeff's son, worked for us for a bit. I didn't put Tom Scholes worked for us for a week emptying the waste paper baskets, but that didn't quite... No, Jamie's the actor. My other son is the actor. Jamie, the little technical presentation, I've got an effect in there, and he advised me not to do it. So I'll show you that in a moment. All right. So this is the, and then I've of course talked for much longer than I intended. So let me just. So those are the people. What else have I got to show you? The other thing that you won't know about, but the bulk of our Jeff and my time in Dyalog, almost the bulk of it, has been doing porting. I don't know if Jeff forgets that, but for the first 10 years, all we did was port to machines. And is that a fair statement? And what happened in 1983, any two men and a dog that could raise a couple of £1,000 would invent a Unix machine, build a Unix machine in their garage, and con us into porting the APL to it. And as soon as we ported it, they went belly up. And Peter, unfortunately, I haven't got a copy of this one, but Pete's got a photograph of one of our exhibitions, and it says, Dyalog APL, now available on Bleasdale B500, Whitechapel something. There are about 6 machines, none of which anybody can remember now. And each one of those ports was desperate. Yeah. So what I'm going to do now, this will impress you. I'm going to write a computer program now. Let me see if I can do this. I may not be able to. It's going to be defun. Let me see if I can do this. I'm only doing this to get a bit of adrenaline going. Let me do this. Where are we going? Quad gets. No, well, if it works, it won't be joke C. If it doesn't work, it will be joke C. Diamond. I'm just trying to show off here. Look, I can write a computer program in front of a crowd. Morton was telling me that Arthur Whitney does this, but what he does is type in a Sudoku solving program in one line. So this is not quite as impressive as this. Right, so what I'm going to do is, with any luck, this will horrify me if it doesn't work, I'm going to randomise these just for the hell of it. Where's your money? What will that do? Let me just do this. This is just for dramatic effect. Okay, these are the ports that Jeff and I did in just in random order. And some of you will remember these machines, but we spent our life doing ports. The ones in parentheses were not completed. The plug was pulled before the end of... Did we do the deck? Okay. I thought there was some reason we hadn't done that. Okay. Well, no. So Dyalog APL at some time was available on these machines, and they were a lot of them were. And I'll show you in a moment. The last thing I really have to show you in this is an example. An archaeologist going through our source code can see remnants of these machines. Yeah, well, I could... The Intel, you think the Intel... I thought you were going to say Gould. Gould was no... Well, I can take the French out. The Bull, the Honeywell Bull is the worst machine ever on the planet. Sorry, why is... I think we started but didn't finish. We had a project to do Apple Lisa, but we didn't we didn't finish it. Oh, that's a quad PW problem. Every year I prepare this demonstration, I practice, and then I plug it into the projector and it squishes my quad PW down. I'd never learn. So when I tried this in my room, it was fine. So... Yeah, I did, well, the way I did, okay, I'm a geek. I admit this. What I did was try setting quad PW equals 1. Try it. That didn't work. Sorry, it's quad RL gets 1. Try it. That wasn't any good. When I got to quad RL 3, it was fine. So I don't get out much. Yeah. So those were the things. And some of these, I don't know what's your least favourite. The Gould was fairly nasty. We started, the Dyalog APL started on a 16-bit machine, the Dyalog, there's no pointy thing. So some of the data structures still remember that they're 16 bits. So if you look at some of the packed bits in the Word, we pack them all into the 16-bit end, and then there's 16-bit spare. I think the second machine we did was the Cadmus, was it? Long since gone. No, the Cadmus was the office machine when the PERT in Farnborough, when PERT was there. We'd done the Cadmus. I'm sure. Sorry? We did an Armdale port. Was that Reading University? Yeah. 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 The Dyalog was the Dyalog. Sorry, I'm hesitating because I've got this. If Flora was in the audience now, there'd be trouble because I'm getting technical. But she's not, so I can carry on. The Dyalog was a 16-bit machine, and it didn't have a floating point unit. It emulated floating point by trapping it. The compilers generated floating point instructions. Whenever the processor came upon one, it went ah, and trapped off to the operating system unimplemented instruction trap. And sometime later, it would add your two numbers together, come back, next item in the array, ah! And so it ran like a dog on floating point, to the extent that at the end of a division operation, if we divided this array by this array, it was worth looking through the result to see if they all happened to be integers, in which case we would demote them. We had coerced dub code, which you don't bother doing now. But on the Dyalog, you really didn't want to get a floating point number. So that was one thing. When we came to do the Gould, did the Gould stretch off the top? The arg on that was the Gould had floating point. It was floating point processor, but the floating point numbers had to be aligned on 8-byte boundaries, otherwise the machine seg-faulted, process crashed. And we hadn't aligned them. We aligned them on 32-bit boundaries. So we had to invent we had to change the heap manager to do that. And I'll show you, this is really the last, last bit of this, and then I must, what else we got? ED, all right. This is not really fair. This is a piece of code that I took from, it's not current code. I took this from an older version of the interpreter, but this is some of our code. And if I look down, let's look. Okay, this is not atypical. This is at some point, I think it's souped up a lot now. At some point, this is the way we divided one number by another in Dyalog APL. This routine from here to here, and right in the middle, there's a C statement to say, take the left arg, treat it as a double number, divide it by the right arg double number, and stick it in the result structure as a double number. But wrapped around it is a whole bunch of, if it's on a machine that has this behavior, then we better do this. If it's an iris, and what is this? A silicon graphics can't detect. Do it this way. So there is still, I don't know, what's CC flag opt? Do you remember that? I don't, but one of the things, when we started porting the C code, I think for the first 20 ports, I'm sure this is right at least, we didn't do a port without finding a number of bugs in the C compilers we were using, so we had to code our way around with these sort of tricks. Well, yeah. Obviously, that division produces TSCE, your point perception, as opposed to what generates not another code. So what we got to do? So you catch that with a signal handler. Yeah. Which change in yeah. And then you come back to this code. Yeah. And the optimizer thinks that you can't possibly change in that instruction. So you've got to actually call a function to quite change. Oh yeah. So that's right. Yeah. These, I mean. We were holed up in little offices somewhere, and you couldn't go home until you got this working. It didn't matter how you got it working, but that was it. So there is now, to Morton's credit, he has allocated time to clean a lot of this stuff up and refactor and do things. But that was just life in the early Unix days. You had to fight your way around compilers. Yeah. I guess so, yeah. Let's go. till Whatcom fix it, yeah. And somewhere there's a CP diff. That was a horrible... What, the bull that was?
No, that's the ICL first.
I think the bull was a CP diff as well.
No, CP diff is completely...
Oh, yeah.
ICL first had word addressing.
Yeah.
If you wanted to address a byte inside the word, the character pointers were 6 bytes instead of 4 bytes.
Yeah. 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 So character pointers were different. So all of this unsint is the IBM 61. We have 4-byte, 2-byte, and 1-byte integers in Dyalog because on the Zilog machine we needed every bit. We'd only got 64K of real workspace, so we needed every bit we can. So a 1-byte int was a really useful quantity. But when we came to do the 6150, the IBM RISC machine, the character, as in the byte integers were unsigned. They ran from 0 to 255. So we had to do tricky stuff with that. Anyway. Sorry? Oh, forget. Sorry. Yeah. Okay. I've overstayed my welcome. All right. Okay. All right. So listen, I don't want to keep you too long. I do want to make this little technical pitch at the end. So let's have. Are there any ducks? Do you want to hear about ducks? So that's all I was going to tell you about the history. Jeff can remember probably better than I can. So buy Jeff a beer. You get actually when you ask Jeff, you get a straight answer. There's no spin on it. That's why Jim always sits next to Jeff. I think you get that. Ducks. As far the official story, I don't know, is that when we did an interface to CGI graphics, we did an AP. Pete was heavily into graphics. He was a graphics freak, and he did some test code. And when he had to learn X. What is it? It would have been X Windows or something, was it? Or it was the graphics book. How to do it? He opened the first page. And there was a polyline which was the shape of a duck with the coordinates written underneath. And he just used that as his example. And he never had another example. So every time there was a graphics demo, this duck would appear. And it just got more and more silly. And at some point, when we first did we would do forms with ducks swimming around in them. And at one point you could take it. When we first did refs, I think, you could have a form with a timer in it, moving a duck around the screen, bouncing off the edges of the pond. And then you could take that ref and put it on a component file, take the workspace away, and then start again and read it back in. And there was the duck still swimming around. So that's where the ducks came from. Questions? The history of Dyalog, tell you anything within reason? No? Okay, so what I'd like to do now, quite seriously, is just a pitch. This is off my own. Let me just close this. Oh, no. Oh, save it, yeah. It's going to say, okay. Oh, yeah. Yes, the Mark I, that was a good idea well, it was a bad idea, and eventually we took it out. On the Mark I version, when you did a paren off, it didn't lose your workspace, it just went off. And when you did go into APL again, there it was again, all your variables, all your functions. So the only way you had to throw things away was paren clear. Yeah, okay, well, the first one was just paren off, just didn't do it. And then people got irritated by this because they'd forget to type paren clear. So we made the system function quad off, the niladic system function. Sorry, say again? Was it? Oh, okay. But that didn't do it. So that's why I think a lot of old Dyalogers type quad off instead of paren off, because that doesn't save a copy of their works, or it didn't. It hasn't for years, but I think you still type quad off. I've noticed you do. You do that, so it doesn't save it. It used to save a file called .apl.active.wus, which was loaded like a super continuum. Yeah? So I'd just like to give you a short technical pitch. Right, this is something that, this is just to show that I'm still thinking about technical matters. This is part of this is my getting older. I'm more and more bewildered by software tools, and on my particular rants are, I'm never quite comfortable with Visual Studio, for example. I just find it too pervasive or too complicated. And what I'm finding is that the software tools complexity seems to me to grow more and more. The complexity of the tools that we're asked to use gets bigger and bigger, and my ability to cope with it goes in the other way. And so this really a pitch to say, when we're designing tools, can we please try to make them simple, make them do the job, but you don't need to put extra bells and whistles on things. This is my plea. So this is a plea for simplicity in PowerPoint, huh? Yeah. And it actually, I mean, it's a design of tools. It's not just software tools. It's any, tools. You don't need a lot of complexity in tools. So, as an example, and this is something I feel strong about. Say we wanted to design a tool, for instance, just a hammer. Okay, this is just an example. We really don't need, exchangeable heads. Hammers, it does the job. It does exactly what it says. And my urge to you is that when we make new software tools, we keep this in mind, that we try to make them as simple. We might make them as simple as possible, no simpler, but no more expensive, no more complex. So, sorry, let me just get this. Hang on. Ed's Hardware Store. Ed speaking. How may I direct your call today? You bought a hammer. Yes, a hammer. Yeah, a hammer, sir, yes. What is your last name, sir? I need it to access the product details, sir. Scholes. Scholes? Scholes! Oh, Mr. Scholes. Oh, yes, sir. As I recall, you're the gentleman who had difficulty leaving the store. I remember you waving your arms up and down in front of the automatic doors. The staff and I wondered if you'd had any formal training for the ballet. No, sir, I don't think that's funny. It's just that you must have used the exit door to gain entry to the store in the first place. So the system had registered 0 or fewer customers in store and had gone into a wait state. Yes. Anyway, sir, the hammer, what seems to be the problem? It doesn't fucking bang things. Well, one moment. Oh, I see you chose the Massomatic SK90. Excellent choice, sir. One of the finest digital lump hammers on the market today. Are you completely satisfied with your purchase? With respect, sir, I think you will find it is of use, and it does fucking bang things. Perhaps you don't have it configured properly. Sir, please. Did you initialize the hammer before first use? Did you use the docking station to charge it for a minimum of 16 hours? Yes. Oh, did you enter the enclosed 16-digit product key? By the way, sir, the SK110, which premieres this autumn, comes with an extra USB and a GPS. Would you be interested in a brochure? No. Did you enable one of the adult security levels? The SK90 is a firm favourite with our mums and dads. You started to bang things and then you had to take a break. What sort of a break, sir? No, perhaps it is none of my business. You said that when you return, the hammer would no longer bang things. Perhaps you exceeded your maximum daily tap quota. Have you consulted the manual to increase the quota? With respect, sir, I can't agree with you that that's insane. You can set the quota to any value. So say you wanted 100 taps in a 24-hour period. You might set the quota to 110 taps to be on the safe side. And then if it became necessary to exceed this, say you encountered an unexpected impaction opportunity, you can easily increase the quota by selecting increased tap quota from the configuration settings in the current project. You only hit 3 things, and one of them was your watch. But it all counts, sir. The system can't be expected to know what you hit unless you had the SK90 Pro Deluxe. Could you read me the 12-digit error code from the display? Please, sir, I'm trying to help you. Just a moment. 0F0897B67A32. Let me see. Ah, yes, timeout. So your hammer timed out. Well, anyone could have used it in your absence, used it in an unauthorized manner. I suggest you bring the hammer into the store for a system reset and a gold star health check. Or one of our technicians could visit you at your home. Minimum call-out charges apply. We cannot guarantee time of visit. Terms and conditions apply. At your convenience. No, I'm afraid I cannot give you a reset code over the phone for security reasons. Well, there might just be one other way. We could try to disable the mechanical locking ring by tapping it sharply to the right. Do you have anything there to tap it with, sir? 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 Thank you. Okay, I guess we should go and drink beer.